Hello everyone, this is Arshi. Today our topic is about bipolar junction transistor. Now what is a bipolar junction transistor? The bipolar junction transistor refers to a three-terminal semiconductor device consisting of two p-n junctions that are formed by either p-type or n-type semiconductors between two p-type semiconductors or n-type semiconductors. Transistors are used to transfer input signals through the circuits having a lower or higher resistance. These transistors are also used to increase the strength of a weak signal. Then construction of these transistors. It is a combination of p-n junctions made up of p-type or n-type semiconductors. The two junctions divide three semiconductors of transistors, that is base, collector and emitter. The emitter and collector are placed either side of this base as shown in figure. Then emitter. The outermost layer of a transistor is emitter. It is heavily doped with n-type or p-type semiconductor material. P-type material employed to produce emitter of a PNP transistor, whereas n-type is employed to produce emitter of NPN transistor. Then base. Base is a intermediate layer. It has narrow zone between emitter and collector, and it is slightly doped. It is made up of different materials than the emitter. PNP transistor base is n-type and NPN transistor base is p-type. Then collector. Collector is a inner layer and it has a modest doping level. The type of semiconductor is same as that of emitter. An NPN transistor's collector is formed from n-type material, whereas PNP transistor collector is made up of p-type material. There are two junctions formed by these transistors, that are base emitter junction and collector base junction. Then types of these transistors. There are two types of transistors: PNP bipolar junction transistors, NPN bipolar junction transistors. Now NPN transistors. P-type material is sandwiched with the two N-type semiconductors in NPN type semiconductor. The two semiconductors of N-type acts as emitter and collector respectively, while P-type acts as base. Here we can see it is a emitter, it is collector and it is base. Next, PNP transistor. The two PN semiconductors are sandwiched with N-type semiconductor in PNP transistors. The two p-type semiconductor acts as emitter and collector respectively, and the n-type acts as the base. The transistor is fundamentally a current control device, hence voltage between its terminal has a significant effect on its behavior. Voltage control. If we talk about input, these transistors is primarily a voltage control device. The base emitter junction voltage determines the current flow between the emitter and the collector, and the base emitter junction flows determines whether the transistor is on or off, and hence influences the amount of current. Next, in a PNP transistors, holes are the charge carriers, and in NPN transistors, electrons are the charge carriers. The Transistor ability to work as switch or an amplifier are determined by the number of charge carriers delivered into the base region. Then current flow. The current flow between the collector and emitter of this transistor is its main output. The voltage across the base emitter junction control base current, which influences the collector current. Here IC current of the collector is equal to beta times of the base current. IC equals to beta into IB. Next, functions of the bipolar junction transistor. It is used for amplification. The bipolar transistors are crucial for boosting electrical signals in devices like audio amplifiers because they magnify signals by regulating a greater current flow between the collector and emitter based on a lesser input current at the base. Next, switching. It functions as electronic switches that regulate the current flow between the emitter and collector. A key element of logic gates and digital circuits, the BJT means bipolar junction transistor functions as a switch by applying signals to its base, permitting or limiting the flow of current. Next, signal modulation. These transistors employed in modulation circuits to change signal properties. It is also used in transmission, communication systems, and used to change signals like amplitude, frequency, or phase by alternating the base current. Next, advantages of these transistors. It Here voltage gain is high. It includes maximum current density. It provides good performance at a high frequency. It has high gain bandwidth, high frequency operation. Voltage drop is low. Operates in low power or high power applications. Then disadvantages: less switching frequency, noise production is more, thermal stability is less, time taken for switching is not fast as compared to high flashing frequency of voltage and current. Next, its applications. It is used as an amplifier, used for the function of the switch, used as an oscillator, used in logic circuits. It is also used in clipping circuits, used as detector and sensors, and so on. Thank you.